Imagine standing on the edge of human knowledge, gazing into the vast, infinite expanse of space, feeling the weight of the question that has haunted humanity for millennia: how did the universe begin? Now, imagine that a single tool, one so powerful and advanced that it seems almost too fantastical to be real, has just opened the door to answer that question, showing us the universe in ways that were once the stuff of science fiction. That tool is the James Webb Space Telescope, JWST, and it is revolutionizing our understanding of the cosmos. The JWST, which launched in December 2021, is a technological marvel, an engineering feat that cost approximately $10 billion and took years of meticulous planning, testing, and design. This incredible machine, larger and more powerful than its predecessor, the Hubble Space Telescope, is already providing stunning insights that are far beyond what we could have imagined. With its 21-foot-wide primary mirror and highly sensitive infrared technology, the JWST allows us to peer deeper into space and further back in time than ever before, enabling scientists to capture light from the very beginning of the universe itself. What has been discovered so far has not only exceeded expectations but has also shaken the foundations of modern cosmology. For decades, astronomers have gazed into the night sky with telescopes like Hubble, and they've made incredible discoveries. They've observed galaxies that formed billions of years ago, they've cataloged distant stars, and they've traced the evolution of the cosmos. But there was always a limit to what they could see. The farther back in time they looked, the less detail they could discern. This is where the JWST comes in. While Hubble was limited by its ability to observe the universe in visible and ultraviolet light, the JWST has the power to peer into the infrared part of the electromagnetic spectrum. This is crucial because the light from the earliest galaxies and stars has been stretched into longer wavelengths due to the expansion of the universe, effectively redshifting it. In simpler terms, the further we look into the past, the redder the light appears. JWST's infrared sensitivity allows it to detect this redshifted light, making it possible to observe objects that are incredibly distant, objects that existed just moments after the Big Bang itself. One of the most remarkable things about the JWST's observations is how they've completely transformed our understanding of the early universe. Take, for example, the recent discovery of extremely distant galaxies. These galaxies are not just far away, they are so ancient that they were formed only a few 100 million years after the Big Bang, a time when the universe was still in its infancy. According to traditional cosmological models, it was thought that galaxies could not have formed so early. The universe, in those models, was believed to be too chaotic and too dense for galaxies to coalesce into the large, structured entities we observe today. But with JWST's infrared gaze, astronomers have discovered galaxies that challenge this very assumption. These galaxies are far older than scientists had ever imagined, and they are more complex and more developed than the Big Bang models predicted. Rohan Naidu, a key researcher in this field, made a groundbreaking discovery just after the first JWST images were released. Naidu, an Indian-American researcher, found a galaxy that existed just 300 million years after the Big Bang, far earlier than anyone had expected. This was just the beginning. Soon, Naidu and his team, along with researchers from other international groups, found several more galaxies that were equally as ancient, stretching the limits of current cosmological models. The shock wasn't just that these galaxies existed so early in the universe's history, it was also their complexity. Some of these galaxies were more evolved, more developed, and more massive than scientists had anticipated. This discovery isn't just a small anomaly, it's a game-changer, prompting astronomers to reevaluate the entire timeline of galaxy formation. For those of us who are used to thinking of the universe as a well-understood entity, this discovery is like a breath of fresh air. It's a reminder that we are still in the early stages of understanding the universe. The more we learn, the more we realize how much we don't know. The discoveries made by JWST have fundamentally altered our perception of the cosmos, and they have inspired a new generation of astronomers to think differently about the universe's history. Many young researchers who were once discouraged by the limitations of previous telescopes are now invigorated by the JWST's findings. These discoveries have rekindled the flames of curiosity and wonder that are the foundation of scientific exploration. What is perhaps most exciting about the JWST's capabilities is that it has the potential to answer questions that we've only been able to speculate about. The search for the first galaxies, the first stars, and even the first black holes, these are the mysteries that drive astronomers to explore the cosmos. And now, thanks to the JWST, we are beginning to see these first objects in exquisite detail. The telescope's sharp images allow us to witness the birth of galaxies, to see the early formation of stars, and to glimpse into the darkness of space where black holes may have first emerged. This is not science fiction, this is real, tangible data that is changing the course of our understanding of the universe. But what makes this discovery so startling is that it challenges one of the most fundamental theories in modern cosmology, the Big Bang Theory. According to the Big Bang Theory, the universe began with a massive explosion approximately 13.8 billion years ago, and over time, matter began to coalesce into galaxies and stars. However, the galaxies discovered by JWST suggest that the early universe was much more complex than previously thought. These galaxies are not just distant, they are ancient, and they are much more fully formed than models of the early universe predicted. They imply that galaxies may have formed much more quickly than we thought possible, suggesting that the conditions in the early universe may have been different from what we previously understood. This is where the real excitement lies, not just in the discovery of these galaxies, but in the realization that our understanding of the universe is still evolving. The JWST's findings are not just confirming what we thought we knew, they are opening the door to new ideas, new theories, and new questions. For decades, cosmologists have relied on a model of the universe that is based on the assumption that the Big Bang marks the beginning of everything. But with the discovery of these incredibly old galaxies, it's clear that the story of the universe's formation may be far more complex than we imagined. Some scientists have even suggested that we might need to rethink the entire timeline of cosmic evolution. Could it be that there were other events or forces at work in the early universe, events that we haven't yet fully understood? One of the most fascinating aspects of the JWST's findings is the discovery of galaxies that existed only a few 100 million years after the Big Bang. These galaxies are so far away, and so ancient, that their light has taken billions of years to reach us. This means that when we look at these galaxies, we are not just looking at distant objects, we are looking into the very heart of the universe's past. The images captured by the JWST are like time capsules, offering us a glimpse of what the universe looked like in its infancy. And what we're seeing is a universe that was already brimming with activity, stars were forming, galaxies were coalescing, and the universe was far more dynamic than we had previously realized. In addition to the discovery of these early galaxies, the JWST has also revealed another fascinating phenomenon, the detection of high levels of ultraviolet light from these galaxies. Ultraviolet light is a key indicator that the galaxies are ionizing hydrogen gas, a process that, according to previous models, should have happened much later in the universe's history. This ionization of hydrogen marks the end of the so-called cosmic dark ages, a period in the universe's history when there were no stars and the universe was shrouded in darkness. The fact that we're seeing ultraviolet light from these galaxies suggests that the process of ionization occurred much earlier than expected, and it hints that the first stars may have formed far sooner than we thought. This is a key piece of evidence that suggests the early universe was more active, more vibrant, and more luminous than traditional models have suggested. While these discoveries are thrilling, they also come with a sense of mystery. We are seeing things that we didn't expect to see, and we are encountering new questions that we didn't even know to ask. How is it possible that galaxies formed so quickly after the Big Bang? What were the conditions that allowed these early galaxies to evolve so rapidly? And what does all of this mean for our understanding of the universe's ultimate fate? The reality is that the discoveries made by the JWST are not just scientific revelations, they are a catalyst for a new era of exploration. The telescope's groundbreaking findings are prompting scientists to reconsider old theories and to come up with new ones. The questions being raised now are not the same questions that were asked a few years ago. The JWST is pushing the boundaries of human knowledge, and as it continues to unveil the mysteries of the universe, we can expect even more astonishing discoveries to follow. As we stand on the precipice of this new era, one thing is certain: the universe is far more mysterious, far more complex, and far more beautiful than we ever imagined. And thanks to the James Webb Space Telescope, we are beginning to uncover its secrets, one galaxy, one star, one black hole at a time. In the years to come, as we analyze the wealth of data coming from JWST, we will continue to refine our understanding of the cosmos. The discoveries that we're making today are not just reshaping our understanding of the past, they are guiding us toward new questions, new mysteries, and ultimately, a deeper understanding of our place in the universe. The universe is vast, and we are just beginning to explore it. The journey has only just begun, and who knows what incredible discoveries lie ahead.